Hi guys, so we are here to discuss the last two pages of the GCSE questions, focusing on the fractional negative indices. So for this question right here, we have the cube root of 4 times 16 times 10 to the power of 15. Now, there are multiple ways of solving this, but we'll go with the shortest one. Now, we know that 4 times 16 is 64. Yes. And we just write 10 to the power of 15 again. Now 64, it's the cube root of 64. We can write it like this. Applying the law that says a to the power of m over n is equal to the nth root of a, m, which is simply the same as nth root of a raised to m. So since they are equal, you can use them interchangeably. Now, you simply use your calculator for this, or we already know that the cube root of 64 is 4, and 15 divided by 3 is 5. So this is in standard form. So in ordinary number, we just write 4 and 5 zeros. So that is 400,000. Moving forward to the next question. This is 3 times root of 3 is equal to 3 to the power of n. As you see, they both share, all these powers are having the same base, which is 3. And we are to find the value of n. So good thing that they all have 3. So we can simply rewrite. So square root of 3, using this concept right here, which I will have to highlight. Okay, I'm just going to increase this one right here. Okay, so let's do that again. There you go. So root of 3 is equal to, that's a square root right there. So this is equal to 3 to the power of a half. Yeah? 3 to the power of a half. Simply rewriting what we have on the other side, which is 3 to the power of n. Now, applying the rule that if we have a to the power of x and you multiply it by a to the power of y, this only applies when you have the same base. This is equal to a to the power of the sum of the indices x and y. So doing that here, we have 1 plus a half is equal to 3 to the power of n. 1 plus a half is 1.5, which is simply 3 halves if you write it in a single fraction. Now, since they have the same base, it follows that n should be equal to 3 halves. So that's 3 halves right there. Did you get it? Okay, for the third one, we are simply applying the same thing. So 3 times, but this time, we have a different base, which is 27. This is to the power of a half is equal to 3 to the power of n. Now, our rules apply only if we have the same base, right? But we know that 27 is 3 cubed. So we can rewrite that as 3 cubed. 3 times 3 times 3 is 27. Just put that right here. So that means it's 3 cubed. Okay? Copying the half outside the bracket. Okay. So now, what is next? So let me just highlight the rule that we use in here. We're going to use and recall a different law, which is when you raise a power to another power. And that is, if a is raised to x, and you raise that power to y, we're not going to add the indices, but we multiply. Or this is the same thing as a to the power of xy. So that means x times y. Now, since we have 3 to the power of 3, or 3 cubed raised to a half, that would mean we just have to multiply the indices. So 3 times a half is 3 halves again, right there. And applying the product rule, in which we just have to add the powers, we now have the base of 3. This is still n. And this is 1. So that is 1 whole plus 3 halves. So if you're doing this without a calculator, 1 whole is simply 2 over 2 plus 3 over 2. So that is 5 halves. So that's what we are going to put in here. Therefore, it follows that the value of n is equal to 5 halves. Okay? All right. Now, this one right here. So it's a matter of manipulating or rewriting the powers so that it will be having the same base. So you can use lots of indices. Now, given that x is equal to 2 to the power of p and y is equal to 2 to the power of q, expressed in terms of x and or y. All right. So going back to the rule that we have here, which they have the same base, we simply add the powers. We're going to work backwards, right? So if that's 2 to the power of b plus q, we can then write that's 2 to the power of b times 2 to the power of q. Because you'll have to add the powers, right? You have to add the indices, right? Now, that 2 to the power of p is equal to x. 2 to the power of q is equal to y. So this is simply x times y. Easy, right? Now let's go to the next one. So 2 to the power of 2p is simply squaring 2 to the power of p, right? Because this is going to be 2 to the power of p plus p, 2p. Yeah, so it's equal to 2 to the power of p squared. Okay, and we know that 2 to the power of p is x, and this is again x, using this. Okay, so therefore, this is x times x, which is x squared. Okay, so t to the power of minus n is equal to 0.2. Now we know the 0.2 is equal to 1/5, right? Okay, now it's easier if we deal with fractions than decimals. So now we just have to write this. 1/5 is, we know it's equal to 5 to the power of minus 1. Yeah, because again, a to the power of minus n is equal to 1 over a to the power of n. So 1/5 is equal to 5 to the power of minus 1. Now we need a positive n for this. Okay, so we have to work on what we have to get to the one that we need. So if I have here a negative n, all right, I'm just going to rewrite it right here, and I need a positive n, I can raise both powers to minus 1. Yes, so that, take a look, what's going to happen in here? As negative 1 times negative 1 becomes now positive n. Okay, and this one right here still becomes a 5. Now it looks simpler and easier. Now we can just square both, because we need 3 to the power of n squared. So we now have to simply square both sides. And that means squaring 5 as well. So therefore, this is simply equal to 25. So answer is 25. Did you get it? Now it's just a matter of manipulating the base, the indices. So as long as whatever you do on the left side is also what you do on the right side, then you're good. Let's have more of practice of the same process. The second question, because it's pretty much the same thing. So this is 5 to the power of minus n, which is equal to 0.5, which we know is a half. Right. And 5 to the power of minus n. Okay, hold on a second. I'm just going to rewrite a half as 2 to the power of minus 1. Yes? Now we need it to become positive for that power of for that index that we have. So let's raise both to minus 1. So negative n times negative 1 now gives us positive n. Negative 1 times negative 1 now gives us positive 1. So it's now just going to be 2. Therefore, we do need to get the value of 5 to the power of n cubed. So same thing. We'll have to cube both sides. Therefore, 5 to the power of n cubed is equal to 2 cubed, which is 8. And that's it. All right. Now solving for the value of n again. So a while ago, I think we answered questions where we have to solve for the value of n, and the powers are having the same base. So the challenge would be, what if we don't have the same base? We have different bases for the powers given. Now, for solving, know that you always have to rewrite the base, okay, to a common one that they can have for you to be able to solve them. If we're not going to use logarithms in here, okay, so we're not going to use working out for logarithms, as we're just doing GCSE level in here. Okay, so with or without a calculator, we can show or we can get the answer just using algebra and the loss of indices that we just discussed. Okay, so this is 4 to the power of n, and this is 8. And now, what is common? 4, okay, can be rewritten as 2 squared and 8 as 2 cubed. Now, how did I get that? I just know that 4 is a square number having the power base, and 8 is a cube number with a base of 2. Right. Now, can I use 4 as a base for both of them? Well, 8 is not a square number for 4 with a base of 4, because 4 squared is 16. So you're not going to get 8. So we have to find the common base that we can use for both of them. And that would be 2. So 4 is 2 squared. Raise to n. We still have to put the n outside. And 8 is 2 cubed. And that's just it. Actually, we don't need to write the brackets. I'm just, write it like that. Now, 2, applying the rules that we have a while ago, this is the second part. So we are assuming that the previous questions already solid. So this is multiplying powers. 2 to the power of n is 2n. Okay, so we're just solving for n here. And that's going to be 3. Now, we do have the same base. So it's an equation. If they have the same base, it follows that the indices should also be equal. So we're just going to solve for the indices now to get the value of n. So we have to equate the indices. So the bases are already equal. It follows that 2n should be equal to 3. Now we should solve for 3, for n rather. So divide both sides by 2 to cancel out the 2 as a numerical coefficient of n. So n is equal to 3 halves. Let me just rewrite that as we need more, and we got more space. So it's 2n is equal to 3. Divide both sides by 2. Crossing it out. So n is equal to 3 halves or 1.5. Doesn't matter. Did you get it? I'll go down to the last question. So moving forward to the last one, I bet you can try it on your own. I'm still going to show you how it's being done. So that's 4 to the power of minus n and 32. Now, again, we need to find the common base for these two numbers, like 4 and 32. And again, 32 is not a square number for the base of 4, also definitely not a cube number with the base of 4. So we cannot rewrite that like that. So the common base for 4 and 32 would be 2 still, because 2 squared is 4, and 2 to the power of 5 is 32. So we can use that fact. So 4 is 2 squared to the power of minus 2. Sorry, my voice is a little, it's Friday, so yeah. Okay, now 2 to the power of 5 is equal to 32, so we're going to use that and replace 32. And now we have 2 to the power of 2 times minus n is minus 2n, or negative 2n. It's the same thing. And now we got 2 to the power of 5. So since, again, they have the same base now, we can simply equate the indices and solve for n. So it's negative 2n is equal to 5. Dividing it by negative 2, as we need to have positive value. The positive 1 numerical coefficient for n. So n is equal to 5 divided by negative 2 is negative 5 halves as a fraction, or negative 2.5. And that's it. That's the second part. Now, assuming that we are done revising the fractional and negative indices of just numbers. So the second part focused on solving specific value of n or x. Okay?